And that was the case today concerning Mount Rainier.
The threat includes Mount Rainier, which scientists continually monitor for activity.
Yellowstone National Park.
Steamboat Geyser, the world's tallest active geyser, just erupted again. Now this is what it looked like when the geyser erupted in 2014, which was the most recent eruption. No activity for 3.5 years, but that has changed. Yesterday's eruption.
Beneath the calm surface of our planet, a red alert has just been triggered. 3 separate volcanoes, thought to be resting quietly, are now showing signs of linking together. Imagine rivers of molten fire moving underground, fusing their power into one colossal force. If even one of them erupted, it would be catastrophic. But if all 3 giants awakened at once, the result could reshape continents. And what satellites just detected beneath the Earth's crust is more terrifying than anyone expected. The Pacific Northwest has always carried an almost mythical aura, a land where emerald forests stretch endlessly and snow-capped peaks pierce the horizon like ancient watchtowers. On the surface, it feels timeless. Serene paradise where rivers glitter in the sun and valleys cradle quiet towns that seem untouched by the chaos of the modern world. But the deeper you look, the more you realize that beneath this postcard beauty lies something restless, something that doesn't sleep. Because under the feet of hikers, farmers, families going about their daily lives, there is a hidden furnace, a place where the earth is far from calm. That's the unsettling truth about this region. Its most breathtaking landmarks are not just mountains, but volcanoes, and 3 of them: Mount Rainier, Mount St. Helens, and Mount Hudar. The kind of giants that remind us how fragile our sense of safety really is. For now, they stand quiet, their slopes cloaked in forests and ice, appearing harmless. But calling them dormant would be misleading. They are not dead. They're only sleeping. And history shows us how dangerous it can be to mistake silence for peace. Take Mount St. Helens, for example. Before 1980, it was known as a stunning, symmetrical peak, often compared to Japan's Mount Fuji. But then came the morning of May 18th, when the mountain unleashed one of the most violent eruptions in modern U.S. history. The blast was so powerful, it erased an entire face of the mountain, killed 57 people, and darkened the skies with ash that drifted across multiple states. That single event proved that the Pacific Northwest's calm could shatter in seconds, leaving scars that last lifetimes. Mount Rainier tells a different but equally chilling story. Towering higher than any other peak in the region, its slopes hold massive glaciers, and with them, the potential for devastating lahars, volcanic mudflows that can race down valleys at highway speeds, swallowing everything in their path. Entire communities sit in areas scientists know could be buried under walls of debris should Rainier awaken. It doesn't need a massive eruption to unleash catastrophe. Even a small one could trigger floods capable of wiping towns from the map. And then there's Mount Hood, Oregon's iconic peak, looming on the horizon near Portland. Though it hasn't erupted in centuries, subtle signs of activity remind scientists that the story isn't over. Together, these 3 mountains form a triangle of risk, a zone where paradise and peril exist side by side. That's why this landscape, as stunning as it is never left unguarded. Networks of instruments, satellites, and teams of volcanologists constantly watch, measure, and listen, waiting for the faintest tremor, the smallest rise in heat, the earliest whisper that the giants beneath the snow might be stirring once more. Because in the Pacific Northwest, beauty is only half the story. The other half is danger, biding its time, far beneath the Earth's surface. Satellites picked up something so unusual that the first analysts thought it had to be a glitch. The thermal scans, usually steady and predictable, were suddenly showing streaks of heat glowing like veins of fire beneath the crust. These weren't random patches of warmth or the typical signature of an isolated magma chamber. No, these looked like threads weaving together into a network. At first, the technicians dismissed it as corrupted data. Satellites misread things all the time. But then, one after another, different satellites captured the same haunting pattern. The fiery glow wasn't vanishing, it was spreading. The images revealed what looked like tunnels, glowing corridors of molten heat, winding and twisting in ways no one expected. To the naked eye, it resembled a map of arteries. But instead of blood, these veins pulsed with magma. Scientists leaned closer. To the screens, stunned. If these tunnels were real, they weren't supposed to exist. Not on this scale, not linking separate volcanic systems across hundreds of miles. It was as though the Earth had drawn secret connections underground, stitching fire to fire, volcano to volcano. At first, whispers in the control room suggested an equipment malfunction. Maybe it was a satellite calibration issue. Maybe solar interference had warped the imaging. But when the European Space Agency's satellite sent back identical results, and then a Japanese satellite confirmed the same anomalies, doubt turned to dread. 3 different systems, 3 different angles, all telling the same story. Something alive was moving beneath the crust. Specialists at the USGS began running simulations, layering seismic data on top of the thermal maps. That's when the full weight of the discovery sank in. The tremors that had been dismissed as background noise now aligned perfectly with the glowing tunnels. Every quake, every faint rumble, matched the path of these underground rivers of fire. The realization hit like a thunderclap. This wasn't a random anomaly. This was a system awakening. By the time the official report reached the USGS headquarters, the tone had shifted from curiosity to alarm. The words no one wanted to hear appeared on the screen. Red alert. It's a classification used only in the rarest of cases. A signal that danger isn't just probable, it's imminent. Researchers who had spent years studying slow geological processes suddenly found themselves staring at a situation that could unfold in days. Even hours. The press hadn't been notified yet, and inside the control rooms, the atmosphere felt electric, part terror, part disbelief. Monitors glowed with images of fiery veins, twisting and branching like some colossal underground root system. And yet, in the silence that followed the alert, single truth cut through. If these tunnels were truly linking the volcanoes, then what humanity had seen so far was just the surface of the threat. Because the most chilling part wasn't that the tunnels existed, it was what they seemed to be connecting. Deep below the crust, as though the Earth itself was preparing to unleash something far greater than anyone had imagined, the first expert voices entered the conversation with a calm tone. But beneath their restraint lingered unease. A USGS spokesperson reminded reporters that the data did not guarantee an eruption, stressing that seismic signals can sometimes taper off without incident. "We need to be cautious in our language," one volcanologist said. "These shifts don't necessarily mean magma is on the move toward the surface." Their words were careful, measured, almost rehearsed, like people trying to keep the public calm while privately flipping through their own worst-case scenarios. Other scientists were far less restrained. A team out of the University of Washington released a late-night statement that cut against the official caution. "The signals suggest that these volcanoes aren't acting independently," they wrote. "What we are witnessing is a synchronized system, interconnected web beneath the crust. If stress is relieved at one point, it could accelerate pressure elsewhere. The possibility of a chain reaction is real." That phrase, "a chain reaction is real," ricocheted across news outlets within hours, sparking debates that grew louder than the steady hum of tremors beneath the Earth. Meanwhile, locals didn't need graphs or peer-reviewed papers to feel the shift. Residents living near the mountains described a strange trembling, subtle at first, then sharp enough to rattle dishes in the cupboard. Farmers spoke of livestock that refused to graze, staring nervously toward ridges where thin streams of vapor leaked through cracks that hadn't been there last month. One hunter swore he saw birds abandon their nesting cliffs in the middle of the night, a dark cloud of wings scattering against a full moon. "It's like the ground is warning us," he told a regional paper, his voice carrying the weight of dread that no scientific report could match. Even among experts, tension deepened as contradictions piled up. Was this a harmless realignment of underground pressure? The beginning of a catastrophic sequence that no human technology could stop once triggered? Some admitted privately that models could not account for 3 volcanoes interacting in such close proximity. The equations broke down, the predictions became blurry, and all anyone was left with was instinct, for many, whispered disaster. Scientists hate uncertainty, but here it loomed larger than lava itself. One volcanologist summed it up during a tense interview: "We are peering into a system that defies our best tools. Maybe nothing will happen. Maybe everything will." That uncertainty is exactly what terrifies them. Three theories rose first: calm and rational, like voices in a crowded room insisting that reason should guide the conversation. Scientists argued that there was nothing mystical about what satellites had detected. The Earth's crust has always been a restless puzzle of molten pathways, hidden rivers of fire twisting and turning in silence beneath our feet. According to this view, the only difference now was activity. These channels had likely existed for millions of years, but only recently had pressure and movement awakened them. It was a reminder, they said, that Earth is alive, breathing, shifting, constantly reshaping itself, fanned, that this new data was part of a long natural cycle. Not a sign of immediate doom. But science's steady voice was quickly drowned out by a darker speculation: geopolitics. If the ground beneath three separate volcanoes was connecting, what did that mean for the fragile web of cities, infrastructure, and nuclear facilities resting above? Analysts whispered about dams sitting on fault lines, underground bunkers carved into unstable rock, and power plants that could be swallowed in seconds if the Earth decided to open its jaws. This wasn't just about lava. It was about vulnerability. If the magma corridors stretched wider than predicted, entire regions of North America could find their foundation compromised, not by fire from above, but by collapse from below. The conversation wasn't geological, was political, military. It's even existential for nations that depended on stable ground. And then came the conspiracies. Pouring in with the speed of wildfire, some insisted that governments had known about supervolcano corridors for decades, keeping the truth locked away in classified reports. According to these theories, seismic sensors and military satellites had already mapped the underground highways of magma, but chose silence to avoid panic, or worse, to exploit the knowledge. In these stories, secret labs were testing how to weaponize volcanic instability or planning evacuation routes reserved only for the powerful. To believers, the sudden admission of unusual volcanic behavior wasn't new information at a lit, was a carefully timed leak, a breadcrumb dropped in a much larger game. Still, others leaned into apocalypse, sketching visions that made even conspiracy theories sound tame. They warned that if these three volcanoes erupted together, it would not be a localized disaster, but an echo of Pompeii on a continental scale. The skies could darken for years, crops could fail, rivers of fire could swallow entire states, and the word America itself might vanish into ash and ruin, where scientists saw magma flows. Doomsayers saw judgment down North America's Pompeii, written in fire and smoke. It was a dizzying clash of voices. Calm science against fear, reason against paranoia, measured warnings against prophetic doom. And yet, through all the noise, one unsettling truth lingered. No matter which theory you believed, the ground beneath was stirring in ways that could not be ignored. And then, just as speculation reached its loudest pitch, a new discovery emerged, one that tipped the balance from speculation to fear. The alarms didn't come with a bang, but with a whisper that spread through monitoring stations like a cold wind. At first, it was the pressure readings beneath Mount Rainier, subtle but undeniable. Instruments buried deep in the rock began reporting surges so sharp they couldn't be explained by ordinary geothermal fluctuations. Then came the gases. Carbon dioxide levels spiked to nearly double their usual baseline, a signal that magma was stirring closer to the surface. And high above, where Rainier's icy crown has held steady for centuries, something was happening that terrified even seasoned glaciologists. Ice on the glaciers was melting in strange, accelerated patches, as if the mountain itself was exhaling heat from wounds it could no longer hide. For decades, scientists reassured the public with models, maps, and simulations. But now those models were failing. The instruments told a story they hadn't prepared for, not just of one restless volcano, but of a chain reaction waiting to ignite. Hidden rivers of magma, once thought to be isolated, were revealing their connections. If Rainier released, its fury The pressure could ripple like a domino across the entire volcanic arc, pulling other giants into chaos. This was no longer the stuff of speculative papers tucked away in academic journals. This was real, raw, and immediate. The weight of this realization was staggering. Picture the Pacific Northwest, Seattle's skyline rising against the water, Portland humming with life, highways packed with millions going about their day. Now imagine it fractured in hours. Roads buried under pyroclastic flows, bridges choked with evacuees, families fleeing with only what they could carry as ash blotted out the sun. The idea wasn't a Hollywood disaster script anymore. It was a possibility staring down scientists who suddenly realized the limits of their expertise. Government officials convened in quiet rooms, drafting evacuation scenarios they hoped would never leave their desks. Reporters sniffed at whispers of unusual activity, but only fragments of the truth trickled into the news. For the people living in the shadow of Rainier, life carried on. Joggers circled lakes. Commuters sipped coffee in traffic. Hikers snapped photos on mountain trails, unaware that beneath their feet, the ground was tightening like a coiled spring. And that's when the most haunting conclusion emerged. This wasn't about whether an eruption might happen decades from now. The evidence pointed to something far more immediate. The glaciers were melting too fast. The gas signatures were too high. The pressure was building at a speed the models couldn't contain. The experts stopped speaking in probabilities and began using words they'd avoided for years. It was no longer just theory. It was no longer a matter of if. Every chart, every satellite image, every trembling sensor pointed to one terrifying truth. This was a countdown, and the clock had already started. Beneath the surface, the story doesn't end with what scientists have already uncovered. It begins there. Because the real question is not what's happening right now, but what happens next. In the best-case scenario, the Earth does what it has done countless times before. Magma shifts, pressure vents quietly, and the subsurface rebalances without a single human even noticing. It's the version of events scientists secretly hope for, the quiet correction that spares us from headlines. But hoping for balance doesn't erase the darker possibility lurking at the edge of every dataset. The worst-case scenario is the chain reaction that volcanologists whisper about in the kind of hushed tones usually reserved for forbidden secrets. If one of the linked volcanoes erupts, it could destabilize the others. Picture three giants, bound underground by rivers of fire, one awakening and dragging the others with it into a synchronized fury. Instead of isolated eruptions, you'd have a catastrophic chain event powerful enough to blanket entire continents in ash. Not a single plume, but a wall of volcanic winter stretching across the globe. The implications are almost too large to measure. The first would be the skies themselves. Ash clouds from a multi-volcano eruption could choke flight paths, worldwide grounding fleets of planes overnight. Picture the silence of airports. Terminals emptied not because of storms or strikes, but because the atmosphere itself has become lethal to engines. Then the ground. Crops rely on steady sunlight, and a thick veil of ash would cut those rays to shreds, triggering harvest failures from Asia to the Americas. Within months, global food chains already fragile would buckle under the strain. And then there's climate. Volcanic eruptions don't just block the sky, they alter it. Sulfur dioxide and ash particles can cool the Earth for years, bending weather patterns, twisting seasons. Imagine summers that feel like winters, monsoons shifting hundreds of miles, off-course droughts where water once flowed freely. Civilization is built on predictability. Nothing erases predictability faster than a wounded atmosphere. The human cost is not abstract. Entire cities sit in evacuation zones where one alert could empty millions from their homes. Economies tied to stability would tremble under the weight of collapsed agriculture, broken trade, and mass displacement. Some experts even argue the ripple effect could rival the devastation of global war, because of bombs, but because of bread, water, and air. And perhaps the most chilling part? The warning from volcanologists is no longer if, it's when. Pressure doesn't disappear. Magma doesn't forget. The Earth's crust may shift the calendar, but the outcome is inevitable. Why one final question echoes louder than all the others. If the Earth is moving toward this reality, so what can we actually do? The mountains always looked eternal, their snowcaps glowing in the sun like guardians of peace. For centuries, travelers passed them without fear, believing these giants would remain silent forever. But deep below, the calm was a lie. What the satellites revealed shattered that illusion, veins of molten fire stretching like arteries, binding one volcano to another in a hidden network of power. Suddenly, the mountains weren't symbols of serenity, were loaded cannons, waiting for the spark. And yet, in the face of such danger, humanity carries on. We build our homes, our cities, our lives, at the mercy of what sleeps beneath us, trusting that tomorrow will look like yesterday. It is both our greatest strength and our most fragile weakness, that stubborn hope in the shadow of forces we can never control. The truth is sobering. Every heartbeat of the Earth carries with it the possibility of upheaval. These tunnels glowing with fire are not just geological phenomena. They are reminders that the ground we walk on is never truly solid, that the crust beneath our feet is a thin shell floating over chaos. We are all of us living on borrowed stability. So the question remains, echoing louder with every new scan, every new anomaly detected by the eyes in the sky. If the Earth chooses to exhale, if the fire beneath these mountains decides to rise, will we be ready? Or will we, like countless civilizations before us, be reduced to ash in a story written not by kings or empires, but by stone and flame? The satellites showed us the tunnels. The question is, will we see them ignite in our lifetime? That answer may come not with warning, but with a roar that silences everything. Until then, we watch, we wonder, and we wait beneath the gaze of sleeping giants.